So now we have a rubber ball that's attached to a paddle by a rubber band. The ball is initially moving away from the paddle with a speed of 4 meters per second. After 2.5 seconds, which means the ball passes, it's moving towards the paddle at a speed of 3 meters per second. What is the average acceleration of the ball during that 0.25 seconds? So what I'm going to do, I'm going to use a couple of different colors here. So I have a ball attached to a rubber band with a paddle on it. Here's my little paddle. So the ball is now moving away from the paddle with a velocity of, what did we say, 4.0? Then after a period of time of 0.25 seconds, the ball is now moving towards the paddle at a speed of 3.0 meters per second. Okay, so it stretches out the rubber band, gets to some maximum point, and then comes back in. Okay, now what it's asking for is the average acceleration during that motion. Now I can tell you right now that the acceleration normally, well, the acceleration in this system wouldn't be constant. It would be changing all the time. But what's important is that we're able to calculate the average acceleration. Okay? So, looking at our definition of acceleration, remember that acceleration is the change in velocity over time. Now, I could put a delta t in there, or I can leave it alone. It really doesn't make much difference. Okay? So now I want to break down my change in velocity. So I can say acceleration is v final minus v initial over t. Okay? Cool? So my final velocity is obviously going to be 3 meters per second. This event happens, and then as time progresses, this event happens. So this is going to be my final. This is going to be my initial. But the important thing to remember when dealing with this kind of situation is the ball is moving this way, then the ball is moving this way. Okay? I'm going to say everything moving towards the paddle is positive, and everything moving away from the paddle is negative. Okay? So I'm going to say motion in this direction is negative, motion in this direction is positive. Okay? So that means that my acceleration is going to be 3.0 meters per second minus a negative 4.0 meters per second all over my time, which is 0.25 seconds. Now, a negative of a negative turns that term into a positive, and then I just add these terms together. So 3 plus 4, 7. So I get 7 meters per second over 0.25 seconds. That makes it a meter per second per second. Okay? Makes it an acceleration. Now I could take this a step further and I can work the rest of the problem out, basically multiplying 7 by 24 and getting 28. But I can leave it as is. I'm pretty happy with this value. So 7 over 0.25 meters per second per second. Cool?